Hello everyone, my name is Chengju, and today I'm going to talk about this small project I made at University of Melbourne. This circuit is an EOG. Basically, it allows us to talk to the computer with just our eyes. Although it looks quite small here, there are quite a lot of things we can unpack about it. So this video will be separated into several parts. We will first go about how EOG works, and then we'll dive into the circuit and talk about what and why I chose them. And finally, I'll talk about some interesting little things I found when making the game. You'll be surprised how much information we can gather just by measuring electrical potentials from our body. Here, this is a simple diagram showing how it works. There is a slight potential difference, around like tens of millivolts of difference between the front of our eye and the back of our eye. So as we look to the left or to the right, this difference will start to show up when you measure between the two sides of our eyes. And this is what we're using for our device. If you're interested about where does this signal come from, there is a link down below in the description that talks more about it. The signal from the EOG is pretty small, around 100 times smaller than what runs on a circuit board. On paper, you may feel simple, just make it big deal. But, well, in the world of engineering, things are really that simple. First of all, if you amplify it, you don't just amplify the signal, you also amplify the noise. What does the noise come from? It may come from, for example, the twitch of your muscles, your phone, or anything that generates electrical magnetic field. So, we'll have to find ways to get rid of these noises, and after that, we also need to modify this signal into something our computer understands. So, this whole thing can be broken down into these several components. First, the sensor, which picks up the signal from our eyes. Second, the amplifier, which makes the signal big. Third, the filter, which removes the noises. Fourth, the analog to digital converter. So now we're talking in the language of computer right now. And 5, an interface to actually talk to the computer. The sensors are made of 3 electrode pads. The black one is the ground electrode that goes to your forehead. The blue and the red ones are cathode and anode that goes to the two sides of your eyes. And our signals will be derived from the difference between these 2 electrodes. The amplifier used here is an instrumental amplifier that amplifies the difference between the cathode and the anode of the signal. The gain can be simply adjusted by this little resistor. The filter I used is a pretty simple one. It keeps the signals in a certain frequency band and attenuates others outside of it. The combination of these resistors and capacitors controls the frequencies at which it cuts off. Lucky for me, this structure is very sufficient for my home. If your environment is extremely noisy, it may be better to use other more complicated kinds of filters, which would not be included in this video. The analog to digital converter is where things start to change a lot. It really depends on what you want to get from the signal. In my case, I wanted to control things on the computer to go left or right, but we have to be more specific here. By control, I mean there will be 3 kinds of state: left, right, and most importantly, do not forget, no input, that is also another state. In the digital world, every information can only be either high or low, but now we have 3 states. So what I'm trying to do here is to make one of the bits high when looking generally to the right, another one for the left, and one that goes high when you look far enough away from the middle of our view. The future me would have said, that could have been done with 2 bits, you know? To achieve the outputs, I used a Schmidt trigger to switch between a positive and a negative state for looking left or right. What's good about a Schmidt trigger is that the threshold for the 2 states are different. So even if there's a slight shift in the signal baseline, it will not affect the output. But exactly how much should the threshold be away from 0? Well, I don't know. So I'm controlling it with a variable resistor for flexibility. Another thing worth mentioning is that the output of the trigger is 5 volts or minus 5 volts, but Arduino does not take in negative voltages. so an inverter is required for one of the states. The other output is achieved by a comparator that returns a high state only when the magnitude of the voltage surpasses a certain threshold. And not just on the positive voltage, we also need it to respond to the negative voltage, so there is a full wave rectifier before the comparator. And finally, all these outputs will be connected to an Arduino board and to the computer. For those of you that would like to try it at home, remember, use Arduino Leonardo instead of the more common one, the Arduino Uno, because Uno itself does not support the keyboard modules, and that would be a no-no for our project. So now, our circuit is able to capture whether you are looking to your left or to your right, or staring far away into the void. Well, I personally very love games, so it's only natural to me to make a game out of it, and what better suits it than an old classic brick-breaking game? On paper, it's quite simple. You want it to go left, look left, right, look right, right? But when you actually play it, it's very hard to control. I'm playing the game, but when I look to the left, there's nothing. To the right, well, great view, but still, not the game. It is like using a walkie-talkie. Inputs and outputs have to take turns. But the ball waits for no one and drops right into oblivion before you get a chance to see where the pad lies. You might have noticed already that there are two things added to the game, and both of them are a way to alleviate the loadings of our eyes. The first thing is the nice little buzz you hear when the pad travels across the board. Firstly, it tells you that you are able to control the pad, that you are really making a difference. Well, not to the world, but in the game. You don't need to check it again and again to know that if something wasn't working in this whole contraption of ours. Secondly, each section has a different pitch. With enough practice, you can picture it moving in your head without looking at it. You'll know where it is and how fast it is going. Another thing I added is the trajectory line. It makes you move faster. Why is that? Our eyes are like a camera. It takes one picture at a time, but in every picture, we only know the location of the object we're looking at. It is only by putting multiple pictures together that we start seeing things moving. So without the red line, we'll need extra time to calculate how fast the ball is going, and even more time to calculate where it will land in the future. And every second we spend on gathering the input is a second lost for controlling the game. So with the red line, boom! Now you know the future. What's better is that we no longer need to check where the ball is. Instead, we can just look at where the lines intersect, and by looking at it, you also know how far your pad is from it. And all in just a little blink of an eye. Thanks for watching it to the end. This project has been a lot of fun. So many mistakes, so many things to learn. Looking back, I could have simplified some of the parts even more. And I drew the PCBs with wrong hole sizes that I have to use other contrived way to work around it. I'm quite surprised that it managed to survive through all that. If you're interested in playing with it, the circuit and the codes used here are linked in the description. This project wouldn't have been possible without the support of University of Melbourne, and especially Dr. Sam John for leading us into this subject and providing us the support and opportunities to bring things to the next level. Finally, for the tradition of YouTube, leave a like if you enjoyed the video, hit the subscribe button, and click on the bell so that you don't miss out any video this channel has not yet any plans for. Thank you, everybody.